Hello, welcome to Online Math Tutorial. In today's class, we'll be discussing binomial theorem. And binomial theorem tells us how to expand expressions in this form. A expressions in this form, A plus B all raised to power n. So if you have expressions, two numbers which you are asked to expand to a certain power of n, that is what we normally discuss in binomial theory. Let's assume you have x plus y all raised to power 2, and you are asked to solve this problem or expand this. So this is what we basically discuss in binomial theorem on how to expand expressions in this form to a certain power. So in this case, we know that s plus y is same as s plus y into s plus y. And when we expand, what are we going to do? We will use all the values here to multiply this, which is same as, if x multiply everything here, we have x into x plus y plus y into s plus y. And this will give us s times x will give us x raised to power 2 plus s times this times y will give us xy plus y times s will also give us xy, and y times this will give us y raised to power 2. And this is equal to x raised to power 2. Xy plus xy is same as 2sy plus y raised to power 2. In this case, we have expanded this expression. So this is what we basically discuss in binomial theorem. Expansion of expressions to a certain power. So meaning that you can equally have something like a plus b all raised to the power 3, and you are asked to expand. So in doing this expansion, because in a situation where you have something like a raised to the power b, a plus b all raised to the power 10, and you are asked to expand, before you can solve this, it will take you a whole lot of time. So there is different ways in which we can use to solve these problems seamlessly. One of them is the one we call the Pascal triangle. And the second one is the combination method. So with these two methods, we can solve problems of expansions seamlessly. Let's assume we are also given something like x plus y all raised to power 3. Automatically, what it means is that we have x plus y all raised to power 2 into x plus y. And I want to use this value we have gotten already from x plus y raised to power 2. So here, if we expand only this, it will give us this, which is x raised to power 2 plus 2xy plus y raised to power 2 all into x plus y. So we now use this to multiply all of this, which will give us, if this multiplies this, we have x raised to power 3 plus x multiply here, we have 2x raised to power 2 y. If x multiply here, we have plus x y square, and y, let's y multiply plus, if y multiply here, we have x raised to power 2 y multiply here, we have plus 2x y raised to power 2, and if y multiply here, we have plus y raised to power 3. So we now add the ones that looks alike. Here we have x raised to power 3, 2x squared, and x squared, they look alike. The difference is the coefficient. Here the coefficient is 2, and here the coefficient is 1. So we can add them. So this is 2x squared y, this is 1x squared y. And when we add two of them together, it will give us plus 3x squared y. We can equally add this and this. This is xy squared and 2xy squared. And when we add, we have 3xy squared plus the last one is y raised to power 3. So in that case, we have expanded this. So if we have something like x raised to power x plus y raised to power 7, this will take us a whole lot of time to be able to resolve this issue. So what do we do in order to solve these problems? We are going to apply all this, either the Pascal triangle or we apply the combination method. So in this class, I'll be teaching you the Pascal triangle method, and in my next video, I'll also teach you the combination method. So let me teach you how the Pascal triangle looks like. Now, if you have an expression in this form, A Pascal triangle, what Pascal triangle shows is only the coefficients of this expression. Pascal triangle will help you to identify the coefficients, the possible coefficients that will come up when you have either x raised to the power 3 or x raised to the power 4. When you have x raised to the power 3 or x plus y raised to the power 3, the coefficient is going to be 1, 3, 3, and 1. So this is what the Pascal triangle shows you, the coefficients of expressions. So here, if we have an expression, let's say a raised to the power 0, it is going to be 1. And if we have a plus b all raised to the power 1, is going to be 1, 1. If we have a plus b raised to the power 2, something in this form, is going to be, and how do you get the next one? Is bring down 1 and add these 2. 1 plus 1 will give us 2, then return with 1. I'll show you how to get the next one. This is for quadratic expressions or expressions that are of power 2. If you look at this, which we solved here, the coefficient here is 1. The coefficient here is 2. And the coefficient here is 1. And that represents that on the Pascal triangle. So if you have something like a plus b raised to the power 3, how do you get this easily? Start with 1. When you start with 1, add these 2, 1 plus 2, it will give you 3. Add 2 plus 1, it will give you 3. And end with 1. If you look at the expression which we solved here, x plus y raised to the power 3, the coefficient here is 1, the coefficient here is 3, and the coefficient here is 3, the coefficient here is also 1. So this Pascal triangle shows you how the coefficients will look like. This is especially when you have only letters. When you have only letters. So for you to get an expression in this form, a plus b raised to the power 4, what do? You start with 1. Add these 2. 1 plus 3 will give you 4. 3 plus 3 will give you 6. 3 plus 1 will give you 4. And you end with 1. To get a plus b raised to the power 5, start with 1, add this to 1 plus this, it will give us 5. 4 plus 6 will give us 10. 6 plus 6 plus 4 will give us 10. 4 plus 1 will give us 5. And you end with 1. And so on and so forth. So if you want to get that of a raised to power a plus b raised to power 6, you are still going to apply the same format. So this is a typical Pascal triangle and so on. You can do this till you get to whatever you want to stop. If you want to get that of a raised to power 6, we have 1, start with 1. This plus this will give us 6. 5 plus this will give us 15. 10 plus 10 will give us 20. 10 plus 5 will give us 15. And 5 plus this will give us 6. You end with 1, and so on. So that is how the Pascal triangle looks like. So we'll be using this Pascal triangle to solve problems, to solve expansion problems in this class. So let's solve this problem, which is expand x plus y all raised to the power 5 using Pascal's triangle. Now to solve this problem, we will say we have x plus y all raised to the power 5. The first thing we'll do is we draw our Pascal triangle. Get our Pascal triangle ready. This is for a raised to the power 0, a raised to the power a plus b raised to the power 1, a plus b raised to the power 2, a plus b raised to the power 3, a plus b raised to the power 4. This is 5 and this is 6. So this is what we are going to consider in this problem. So to expand this. So to do this quickly without going through the rigorous process of multiplying and multiplying and multiplying. So this is how you're going to do it using Pascal's triangle. So the first thing you do is you take the first one. The coefficient there is 1. The coefficient here is 1. The first one, which is x. That's the first one you take, x raised to the power 5. The coefficient is 1 plus the second one is, what is the coefficient here? The coefficient here is 5. 5 and x, you take x, the power of x will reduce by 1 and the power of y will increase by 1. Meaning, you bring in y. Here, you now have 5 minus 1 and you now bring in y raised to the power 1. Meaning that 5 minus 1 is 4. When you add the two powers, it will also give you 5. So all the powers which you are going to have here, when you add them, they will definitely give you 5. So the next one is you take the coefficient x, subtract 1 from the power already, and bring in y. The next step is you have the coefficient as 10. Now, x, what is the power here is 5, subtract 2. The first one you subtract 1, the second one you subtract 2, and increase the value of y. So meaning that since y is 1 here, y will now be 2 here. and so on. The next, this is also equal to, this same as continuation, plus, we have the next coefficient, also 10. 10 x 5 minus 3 y raised to power, here y is 2 and y is going to be 3 here. As s is reducing, y is increasing. Plus, the next coefficient is 5. 5 x raised to power 5 minus 4 y raised to power 4. The last one is 5. Okay, last one is 1. The coefficient is 1, and you only take the value of y. Or if you also want to solve it, you have 1 x raised to power 5 minus 5 y will also increase to 5. So when you solve this, you are going to have x raised to power 5, x raised to power 5 plus 5 x 5 minus 1 will give us 4 y. Y power 1 is also y. Plus 10 x raised to power 5 minus 2 is 3 y raised to power 2. So when you look at this, you'll find out that while x was 5 here, and here x is 4 here, here x is 3. X will be reducing and y will be increasing. Plus 10 x 5 minus 3 will give us 2, and y is equal to y raised to power 3. Here, plus the next one, which is 5x raised to power 1, because 5 minus 4 is 1, y raised to power 4. So when you look at this, you find out that if you add the powers, they will definitely give you 5. 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4, and the last one, which is x raised to power 5 minus 5, x raised to power 0, and x raised to power 0 is 1. Any value raised to power 0 is 1. So you'll be left with y raised to power 5. So with this Pascal triangle, you have bypassed all the rigorous process of multiplying and multiplying and multiplying numbers, or multiplying values or variables. So with this, you can easily use 2 or 3 lines to be able to get an expansion of x plus y raised to power 5. So that is one. The second example is, so look at the second example. This is entirely different from what we did initially. And in this case, instead of having a variable here, we have a number. So we are asked to expand this. All raised to power 4. So these are basically some of the ones you'll be seeing in your examinations or what have you. So we are asked to expand this problem. And this is all raised to power 4. Solution, we are also going to use our Pascal triangle, which we have already here, to be able to solve this problem. So we have that 2 plus 3x all raised to power 4 So applying this exact same thing we did, bearing in mind that this is a number and we'll be looking at this number as just a variable, we can also solve this problem. So what we'll be considering here is the one of a plus b raised to the power 4, because these are the coefficients of what we are going to solve of this problem. These are the basic coefficients of what we are going to of this problem we have here. So to do this, we say this is equal to, we start with the first one. What is the coefficient of the first one? The coefficient of the first one is 1. Dot. This dot here means multiplication. This number, which is 2, all raised to the power of 4. Assuming it is x or b, we are going to have 1 dot a raised to the power 4. Assuming this is a variable. So in this case, a number. Here, this dot is not 1.2, it is multiplication. Plus, what is the coefficient of the second one? Is 4. So we have 4, that is the coefficient, dot 2, all raised to power. Like I said, the powers will be reducing, and you bring in this. The powers of the first value here will be reducing, and you bring in this. So we have 2 dots 4 minus 1. Then you bring in these other parts of the expression. Dot 3x all raised to power 1. Let me use brackets to avoid confusion. Let me use brackets. So the next one is plus, watch carefully. You have taken the first coefficient, which is 1, the second coefficient, which is 4, the third coefficient is 6. 6. So we have 6 open brackets. We take the first one, like we said, it will be reducing. We have 2 raised to the power 4 minus 2. We have 6, which is the coefficient. Then we'll take the first value here, which is 2, all raised to the power 4 minus 2. The powers will be reducing. And in this case here, the power of this will increase, which is 3x all raised to power 2. So we've gotten for the third one. The next one is the coefficient is 4. So this is equal to 4 open brackets 2 raised to power 4 minus 3, 4 minus 3, close the brackets, put another bracket. For the next one, we have 3x all raised to power 3. As this is increasing, as this is reducing, this is increasing. Here we have 3x raised to power 1. Here we have 3x raised to power 2. And here we have 3x raised to power 3. And ensure that this power here covers the two values, covers both 3 and x. If you cover only with x, you will get it wrong. So the last one is plus. Here we have 2 raised to power, the coefficient is already 1, into 2 raised to power 4 minus 4, all into, we have 3x all raised to power 4. The next thing we'll do here is we resolve all this. So we have this to be equal to 2 raised to the power 4 is 16, which is 2 times 2 times 2 times 2. And that will give us 16. So this is 16. That's 2 raised to the power 4 times 1 to give us 16 plus. This is 2 raised to the power 3. 2 raised to the power 3. That is 2. 4 minus 1 will give us 3. And what is 2 raised to the power 3? 2 raised to the power 3 is 8. 8 times 4. 8 times 4 will give us 32. So we have 32 into x 3x plus 2 raised to the power 4 minus 2. 4 minus 2 here is 2. So we have 2 raised to the power 2. And 2 raised to the power 2 is 4. 4 times 6. 4 times 6. Well, let me break it down. Here we have 4 into 2 raised to the power 3 into 3x plus 6 into, this is 2 raised to the power 2, 2 raised to the power 2 into 3x raised to the power 2 is same as 3x raised to the power 2 is same as 3 raised to the power 2 x raised to the power 2. And 3 raised to the power 2 is 9. So this is 9x raised to the power 2 plus, here we have 4 into 2 raised to the power 1 into 3x raised to the power 3. 3x raised to the power 3 is same as 3 raised to the power 3 times x raised to the power 3, which is 27x raised to the power 3. So we have here to be 4 2 x raised to the power 2 raised to the power 1 into 27 x raised to the power 3 plus 2 raised to the power 4 minus 4 is 0, and 4 minus and 2 raised to the power 0 is 1. So we are left with this. So we have, and 3 raised to the power 4 will give us 81 x raised to the power 4, because 3 raised to the power 4 is 81. So if we go further, we will have 16. We will have 16 plus 2 raised to the power this is 8. Is 8. 8 times this will give us 32 into 3x plus 2 raised to the power this is 4. 4 times this is 24 into 9x raised to the power 2 plus 2 raised to the power this is 1. 4 times this will give us 8 into 27x raised to the power 3. Then we'll be left with here plus 81 x raised to the power 4. So this will give us 16 plus 32 times 3. 32 times 3 should give us 96. 96x plus, if you multiply 24 times 9, multiply it, it will give you 216 x raised to the power 2 plus 8 times 27 will also give you 216 x raised to the power 3 plus 81 x raised to the power 4. So this is the expansion of this. And we did this using Pascal's triangle. Assuming you want to expand this without even using the Pascal triangle, this space will not be enough, will not contain this, because you'll be multiplying them one after the other, one after the other, so as to get the value of this expansion. So when you expand 2 plus 3x raised to the power, all raised to the power 4, it's going to give you 16 plus 96x plus 216x squared plus 216x raised to the power 3 plus 81x raised to the power 4. Thank you for watching. Please remember to subscribe to this channel, follow us, comment on the comment section, click on the notification bell so that we'll be dropping videos like this. Anytime we drop video like this, you will also be notified. And also give us hints on what you want us to solve for you on the comment section. Thank you and God bless.